Now let's look at replacing slurpd replication with SyncRepl replication. SyncRepl is the newer form of replication supported by OpenLDAP. Replication with SyncRepl. It's more efficient and more reliable. So more efficient and reliable than slurpd-based replication. Additionally, it's implemented as a slapd thread. So when you configure SyncRepl replication, a separate thread, a separate slapd thread is instantiated to handle the replication. The model differs from slurpd in that both push and pulls are supported. And let's just elaborate a little bit on this particular feature. In push mode, the SyncRepl process uses what's called refresh and persist. Configured on the client, otherwise known as, or also known as the consumer, refresh and persist instructs the server or the provider to constantly supply the consumer or the client with updates. So this is analogous to a real-time replication option. So close to real-time replication option. And this option should be used in well-connected environments. So note, use refresh and persist method in well-connected environments. Unless, of course, your LDAP DIT is small and you're only pushing small changes. In addition, on the pull side, refresh only is supported. Refresh only works on intervals. So updates consumer or client DB on intervals, and these are defined intervals. So we've got two methods of moving the data between the provider, which is the server, the master, and one or more consumers. We may use refresh and persist for well-connected environments, and this will get you as close to real-time updates as you can, or refresh only with a defined interval, which can be as small or even smaller than the default slurpd replication of 3 seconds. And the model changes from a single master to a provider, which is basically the master, and consumers, which are clients, relationship. It sort of looks like a single master relationship, but it differs in that any consumer can subsequently become a provider to subsequent consumers, which leads us to our next configuration feature, and that is it also supports, this is SyncRepl, cascading configurations, which basically means you have a provider, meaning the master or owner of the DIT where you commit changes, and that provider supplies one or more secondary providers. And secondary providers, one or more, are basically consumers who become providers to other consumers. So this is a cascading relationship that can be configured, whereas with slurpd you're relegated to single master. Note, by contrast, slurpd, and let's just uppercase this, restricts us to single master replication, which means all of the clients have to log into the master to download the latest updates. Looking at our graphic, what this means is this is our primary server, which will become the provider. One or more clients or one or more consumers, such as Solaris 10 or Red Hat Enterprise 5, can download directly from the primary the latest updates, and those are incremental updates when using SyncRepl. However, we could configure a cascading environment such that the Red Hat Enterprise 5 box, for example, becomes a consumer of or client of the primary SUSE Enterprise 10 box, which functions as a provider, and then, perhaps if it's better connected to the Solaris box, becomes a provider to the Solaris 10 box, or vice versa, either way. But you have that flexibility with the new SyncRepl configuration. Let's note also that the configuration in this environment is defined primarily on consumer servers, not the provider. Now, that doesn't mean that you cannot define configuration directives which impact SyncRepl on the provider. You can, in terms of what to log, session logging, which improves the amount of time it takes to replicate your DIT, in particular when your DIT happens to be large. But by and large, configuration takes place on the client, which means no changes are necessary to the server. So note, none to few changes are required on the provider or server, which means we can feel free to set up our directives and watch the DIT propagate. In addition, specific queries or searches can be replicated, which means we can restrict our replication to specific searches, including specific attributes. Now again, this all depends on the size of your DIT and how your organization is laid out and what information needs to be where. For our intents and purposes, we will configure replication for the entire DIT, which means from the base DN, DC equals Linux CBT, comma DC equals internal, and configure it with the sub option so that all sub objects or subordinate objects are replicated. But you can specify specific searches. We should also note that SyncRepl is search based, which basically means searches define what gets replicated. If you indicate a general search such as object class equals star, then all objects, at least at that level and perhaps at sublevels, will be replicated. So the searches define what gets replicated, and the searches or search criteria is identical to that of LDAP search. So however you would normally define a search with LDAP search is how you can restrict SyncRepl. So it's based on the same syntax. There are many other features, but these are some of the key features. Now with that said, we should set up some tasks. One is to select a slave server or a current slurpd slave server, remove its DIT, and configure SyncRepl. So configure sync replication. And we should also note that the SyncRepl process makes use of the built-in LDAP synchronization protocol as a 9th feature. Uses built-in LDAP sync, and that's the content synchronization protocol. So we'll be configuring SyncRepl on our Red Hat 5 box. Now a number of tasks are required. First, we should disable. It's generally not a good idea to make use of both slurpd and SyncRepl simultaneously, as they are both replication protocols, distinct replication protocols. So we'll disable slurpd replication altogether. And to do that, we update the configuration files of all of our systems. So let's begin with the server. Let's nano etc open LDAP, and we'll just comment out the items relating to slurpd configuration towards the end of the document, where we have both replicas defined. commenting this out. We'll leave it here in the event that we want to resort to it, although SyncRepl is a superior form of replication. So the server will no longer, after we restart the slapd service, replicate items because the directives have been removed. On the Red Hat side, let's also update OpenLDAP slapd-conf and find any items that cross-reference the server for replication. Let's just search through here. And we've got an update dn. This is what's returned with respect to updates and an update reference, so there is nothing slurpd specific jumping out at us, which is fine. So with that said, since again slurpd is push based, the updates are sent from the server, very little has to be done on the client side. So disable slurpd replication altogether on the master server, which for us is Linux CBT SUSE 2. And of course that also means to restart slurpd on the server. So let's rc ldap restart, and that'll restart slapd, and we no longer need slurpd, so we can rc slurpd stop. Replication is no longer required, so it's now disabled. Then we need to clear the DIT. So next step is to delete DIT on one or more slave servers. Since we're working on the Red Hat 5 box, we'll delete from there. Now we can take LDAP delete from our nodes and ensure that recursion's turned off and ensure that we're referencing the appropriate base to be deleted. So for example, here's an LDAP delete command. We can tailor this to suit our needs. Let's return to the bottom and update it to work recursively. We want to delete from the base, and we can, if we'd like, remove even the base DN, as SyncRepl will recreate this container if it doesn't exist. It must be recursive, will be prompted for password, simple authentication, it will be verbose, and will bind as the following. Let's try this, and we'll confirm that the items have been deleted subsequently by using LDAP search. We're going to do this on Linux CBT Serv 4. This goes through all of the nodes and removes all of the items for us. And there are many services and protocols to be removed, so it will take a little while. But nonetheless, momentarily we'll confirm that the items have been removed using LDAP search. Let's just update our notes while that runs. So step C will be to confirm the deletion with LDAP search. LDAP search should return no values, no results, no records. And then after we've confirmed with LDAP search, configure consumer server, which is basically the client, to use SyncRepl. And there are a number of directives that need to be indicated, which we will point out momentarily after we confirm the current status of the deletion. But this is where we specify all of the key directives that drive the SyncRepl process. Now, since this is still running, let's start defining, in the interest of saving time, the SyncRepl items. The first line begins with sync replication, and there's no need to remember this. You can man slapd.conf to get more information about sync replication. We need to define an RID, which is a unique identifier governing this replication. For example, one of the features of SyncRepl is the ability to replicate multiple branches, specific branches, etc. So you can set up different replication instances via unique IDs. We specify an RID and we set it equal to a value such as 001. The value must be a positive number up to a maximum of 3 digits. So 001 suffices. So it's limited to 3 digits. But the documentation tells you that. We need a provider. We need to indicate the provider URL or URI using LDAP and the host name or IP address or short name, but we'll opt to use the long name, the fully qualified domain name. And we can indicate a port 389 or have SyncRepl default to 389. That is the default port. That specifies the provider. Now, if your provider is configured with LDAP Secure, then you could indicate port 636 or change the URI from LDAP to LDAP Secure, which defaults it to 636. Or if you're on a different port, then just indicate the port. Now we'll also indicate the type. Now we indicated above that there are 2 types of replications supported, refresh only and refresh and persist. Refresh only is a pull configuration. This directive is driven primarily by the next directive that we'll define, which is named interval. Whatever the interval is set to is how frequently the consumer will pull information from the provider. So you need to be mindful of that when configuring your server to replicate. And obviously the benefit to the refresh only pull method is that we can tweak or fine-tune just exactly how frequently the client will pull information or attempt to pull information from the provider server. That works well in low bandwidth areas. So type refresh only, we'll try that initially and set an interval. Now the syntax for the interval is DD, hour, month, second. We can start off perhaps with synchronize every 1 day, followed by 0 hours, minutes, and seconds, which means every 1 day from whenever we started the process, synchronize or pull the latest DIT from the server. Again, in a very poorly connected bandwidth-wise environment, this would be ideal perhaps, or maybe a shorter interval, or an interval that would coincide with off-peak usage. There's another optional directive that's retry. If for some reason during a replication interval or a replication attempt there's a failure, we can indicate, sort of like with DNS to slapd, to retry on a given interval and for a number of retries. So for example, we could say retry 10 times for the number of retries, the second directive, every 15 minutes, or every 15 seconds, or every 1 day. If you indicate a number such as 60, it means seconds. It's the base unit. So a retry, 60 followed by number of retries, let's say 10, in the event of a failure will cause the SyncRepl process every minute to retry up to 10 times. And there's an optional plus that we can indicate which tells SyncRepl to retry indefinitely. Again, retry is optional, but it helps in the event of poor connectivity, which is quite likely. Perhaps the provider is going through a reboot cycle or is unavailable due to a current backup, which is consuming the bulk of the bandwidth, or for any reason. Now let's move on to some more important directives, including the search base. The search base is important. For our intents and purposes, this will be the root of the DIT. Looking at this graphic, that basically means everything from the root down, including all the OUs, users, groups, etc., services and protocols that we've imported thus far. And this is finally finished. We'll get back to that in a moment. We'll set the search base to be DC equals Linux CBT, DC equals internal, but bear in mind that you can indicate any branch. For example, you could specify a search base of OU equals people, DC equals Linux CBT, DC equals internal, and only objects beneath this particular organizational unit will be replicated. May come in handy depending on what you're doing. Our search base will be the entire DIT because it's small. Filter. Now this is where the syntax matches LDAP search. In between parentheses, we'll indicate object class equals asterisk, which means every single object type beneath the base, including the base, is to be replicated. But in terms of filtering downwards, that's a separate directive. It's called scope. We indicate the scope, which tells SyncRepl whether or not to drill down beneath its current level. Options include sub, 1, or base. Remain at the base, go one level down, or flow all the way down until there are no more levels, which is what we prefer because our DIT is small and it gets our point across. But again, if you are replicating perhaps just one OU, then perhaps you'd indicate just one level or the base that you're at, or maybe 2 OUs, or whatever your tree dictates. We find that replicating the whole tree for our small classroom environment is ideal, but the scope directive governs how much information is returned in the search. Think of SyncRepl as a means of executing a search query against the LDAP server, the provider server. It formulates a result set, and that result set is replicated to the consumer in an incremental fashion, which is a 10th feature. And that is that replication is incremental. And there are ways to tweak the incremental replication so that it's faster, especially for larger DITs. But the replication is incremental. So searches are executed, performed on the provider, and the provider compiles that result set and returns the incremental differences to the consumer, which is the client, one or more consumers. And one or more consumers can become one or more providers for subsequent clients. Now again, all of these settings here pertain to the SyncRepl instance referenced by RID equals 001. We could define other SyncRepl instances, perhaps for replicating other branches or other searches. Now in addition to scope, we should define the bind method, no differently than we did with slurpd replication. We'll set this to simple for now. We've yet to turn on SASL. We must indicate the bind DN, CN manager, DC Linux CBT, DC equals internal. And last but not least, credentials, which amount to the password to be used to authenticate to the provider. So basically, think of SyncRepl as a means of conducting a search which is returned and incrementally replicated to the client. Now, what governs whether or not the relationship is a push versus a pull is whether or not you use refresh only versus refresh and persist. If using refresh only, the interval directive governs how frequently SyncRepl pulls the information from the provider. If using refresh and persist for SyncRepl replication, then the search is constantly executing on the LDAP server, and as soon as an update is made to the provider, it is replicated across. So it's as close to real time as we can get using this mechanism of replication. So these are some of the features: push, pull, etc., incremental changes, and the changes are made primarily on the client with optional tweaks that can be made on the server, which relate to configuring primarily the session log, which helps with synchronizing the changes. It speeds up the synchronization of the changes. Now, one other entry we should add, and that is a modified index on the following fields: object class, entry CSN, and entry UUID, setting them equal. The reason why we want indexes or indices on these particular attributes is that they'll be used very frequently now that we're using SyncRepl. In the case of this interval, it's going to be executed once a day, but in the case of refresh and persist, it will be as often as possible. So the more you hit the LDAP DIT with search requests, the more you'll benefit from having indexes. And these are the attributes that are most frequently hit. Now you will see, if you turn on debugging, sometimes other attributes that LDAP complains about, such as member UID, if member UID is searched frequently, or any attribute that's searched frequently that doesn't have an index. It's a warning to you, or a notification to you as the administrator, that if you set an index on the field that it's complaining about, the replication process will execute faster. So let's copy these directives and paste it into the slave server configuration. Let's nano, execute a recent instance of nano. And by the way, these directives are defined beneath the database section. And notice there are multiple indexes or indices defined on the Red Hat box that are not defined on the SUSE box. Define your replication beneath the DB section. So there are additional indices. We see object classes already defined. Entry CSN is not. Neither is entry UID. So from this we can remove object class or comment object class above. And it will be reindexed or indexed, that is, on this line. Let's just include a comment which indicates clearly that this is SyncRepl replication. And this directive block can be used on subsequent servers. Now let's save the changes and then confirm that all of the objects have been deleted by executing an LDAP search. Notice no objects. Nothing's been returned. Everything's been wiped from the server, including the base DN. Not from the primary, of course, but from the secondary. If on the primary we attempt the same search, LDAP search, and this is a search which performed on the remote system, and let's try it again, and there are the entries. So that was a search of just the group OU, which initially turned up nothing. And if we go through the entire tree, then I'll just scroll and scroll for all the entries. So the primary still has the settings. However, let's look at the secondary server, and it has a few entries that are in, which means that the replication is still in place in memory. So as far as SyncRepl is concerned, let's just make sure that our service on the remote system, let's etc initd stop the LDAP service and then start it. And we'll try it again. Sometimes during the sync process we'll get a SyncRepl failure like we see here. So let's try starting it again. And this time it started successfully. Now let's check our search to be sure that the items exist locally. Changing this to host localhost. And we should see, and these are organizational units, all exists. Let's search for all items through all levels. And this will search the entire tree, which returns all services, protocols, etc. So SyncRepl took care of this replication from the server. Now, of course, if we add a new entry on the provider, it will not be updated immediately. So our next task is to create new object on provider. It can be any type of object. We have experience creating users, groups, etc. So we can pick any object from the past, make a change, and add it. For example, let's LDAP search in the people OU. And it returns a list of people configured. Prod user 2, which we did not update the DN from our last section, which we need to. Let's create a user naming the user prod user 3, which is uniquely identifiable. So we'll paste the items and update the comments to reflect prod user 3. The object classes are fine, and the UID will be set to 1006. GID number 100 is fine. Home directory prod user 3. CN should also be prod user 3. And the UID at the bottom should be prod user 3. The default password, which is encrypted from prod user 2, will suffice. Using LDAP add, we can add this user to the master server. Let's history grep LDAP add, and we'll take instance 720, which prompts on standard in for a password. and then waits for us to paste our entries. And then it adds the new entry to the directory. And if we rerun LDAP search, we will see momentarily of the people OU. Let's try it over on this system, that it lists everyone up to proj user 2 but no proj user 3. Now in the case of SlurpD replication, 3 seconds would have already elapsed or has already elapsed and the data would have been replicated, but SyncRepl allows us to fine-tune the replication such that it will not try for another day. Now how about if we kill slapd running on the Red Hat box using service LDAP stop and then service LDAP start. This restarts the service, and then we'll rerun LDAP search, and what you'll see is that it has not updated its database to reflect the latest user because we've set replication to be every day, and the consumer keeps track of the incremental differences. So if we modify etc openldap slapd.conf, updating the model from the current refresh only to refresh and persist, then it nullifies the interval or ignores the interval directive and executes the search query all the time on the server, which means as soon as a change is made, the change will be reflected. Or if we reduce the interval to something like every 5 seconds or 3 seconds and continue to use refresh only, then the changes will take effect. Let's save the changes here. Service LDAP, well, it's already started, so restart. And if we try the search again, we see project user 3 in the DIT. So we've gone through a little bit of SyncRepl. There's obviously more that you can do with it in terms of tweaking its synchronization processes, but it is the new tangent, the new method that you should employ when replicating your DIT or fragments of your DIT between LDAP hosts. Now before we go, let's just configure SyncRepl replication on Solaris 10 by copying the configuration we used for our Red Hat Enterprise box. So our third task is to replicate sync replication configuration on Solaris 10. We'll copy the SyncRepl block. The RID can be the same, but just to keep it distinct, we'll make it 002, and it will point to the same LDAP provider using either refresh only or refresh and persist. If refresh only, then set a low interval such as every 5 seconds, similar to SlurpD replication, and this will replicate the whole tree. Now to prove that replication actually works, the suggested tactic is to remove all of your DIT information from the slave by preferably wiping the directory structure where the LDAP database is stored. But you may optionally use an LDAP delete. Let's copy this block over to Solaris 10. And we need to navigate into user local, where the configuration for OpenLDAP is stored. Navigate towards the bottom where replication is enabled. We can disable for now our update DN as well as update reference pointers, and then paste in the SyncRepl. Now, along with SyncRepl, we should set indexes on the attributes that we've assigned for replication, which include the original object class. These are the search attributes: entry CSN, entry UID, and any other attribute which shows up in your LDAP log. Since object class is included here, and we'll just make it upper C, let's disable it here. So this will point to the provider and download the changes. However, again, the suggestion is that you wipe the database because the local instance has a copy. If we history grep LDAP search and find an instance which ran locally, for example, let's pick 460, and this is a local dump, that is. It's yet to download any changes because we've disabled slurpd on the provider server, so there are no new changes being replicated to the Solaris 10 box. But there are still records in the local database. So one suggestion, as we've mentioned, is to entirely wipe the local database by removing the files associated with the OpenLDAP instance. Let's navigate into var openldap-data. This directory contains the various databases. If we wipe these files with LDAP stopped, meaning after having killed the slapd instance, and then restart LDAP and cause SyncRepl to download, then the entries will be copied verbatim from the provider. So a subtask of 3 is to try a different approach. Manually wipe the Solaris 10 LDAP DB directory. This ensures that all records, although it may take a little while to download, are consistent with the provider. And to do so, we simply remove everything from the user local var openldap-data directory, which is where OpenLDAP sets up shop. If you do have a db_config file, save that file. It has tweaks which facilitates performance enhancements or performance increases in the LDAP or slapd engine. But this file is currently not read because it has a suffix of .example. So let's first execute a kill. This will kill slapd. We'll psef grep just to be sure that it's not running. Then we'll remove rf*, which will wipe everything from the current directory. So now that it's gone, we can restart slapd. Let's history grep slapd and find an instance where we started it, 522, for example, in our history. Echo the exit status and then psef again. Now slapd is running and it's going to rebuild its database. Now let's LDAP search again. Now what we see here are records being quickly downloaded or re-downloaded from the primary server because we've wiped manually the database files. So this is SyncRepl in action using refresh only every 5 seconds. Let's perform a drill down search of the people OU to ensure that our newly created user has made it, and there's the newly created user, ProdUser3. So SyncRepl is working as expected. So we've configured SyncRepl on both Red Hat and Solaris systems. Let's just double check the Red Hat system by rerunning an LDAP search on the local system. There we see ProdUser3. And the number of records returned entirely should be the same across all 3 systems, providing that SyncRepl has done its job. So here's a search which returns all of the entries, 500 on the Red Hat side. Let's try on the SUSE side. And the connection in that case has been dropped, so let's reestablish it and execute an LDAP search of the base DN, which should also return 500 entries. So it also has 500 entries. And on the Sun side, this will search the people OU. So let's drop this to be the base DN, and it also returns 500 matches with a little error at the end that the size limit exceeded, which we can tweak by altering LDAP search. So SyncRepl is in place. Just a quick recap. Let's look at our graphic to describe what's happening here. Our primary server is still, primary or provider server is still the SUSE Enterprise 10 box that I'm hovering over. We've configured it to disable slurpd replication, which is the original replication provided with the OpenLDAP application. we've enabled SyncRepl. SyncRepl requires that we configure the clients, the consumers, to download updates from the provider. Those clients or consumers include the Red Hat Enterprise 5 and Solaris 10 boxes. We started off by configuring the Red Hat Enterprise 5 box to download from the provider. It replicated changes. And we followed up by doing the same on the Solaris 10 box, and it also downloaded the changes as well. Now there's one other note regarding SyncRepl that we should point out, and that is the provider configuration. The provider configuration, the server, should include 3 directives. OpenLDAP facilitates additional functionality or modular functionality using the terminology overlays. One of the overlays is synchronization provisioning. So you should at some point update your provider server to include the following directives: overlay sync provisioning, checkpoint, and we set it to 110 for 100 entries, and sync provisioning session log. You can consult the documentation for the meaning of these entries, but basically they're not required, but they allow the SyncRepl process to operate much more efficiently by allowing the server to partake in the process with respect to keeping track of items that have been replicated to the various consumers. So update provider, or what was formerly known as the master server, in the DB section of slapd.conf. But you can configure slapd on the clients or on the consumers to enable SyncRepl without configuring the server. These directives simply tweak the process and make it more efficient.